The 1996 National Electrical Code, or NEC, introduced a requirement that new 120/240 volt circuits must have a 4-wire cable. This consists of 2 hots, a neutral, and a ground. This requirement was implemented to improve safety and prevent electrical shocks. Adding a receptacle to an existing 3-wire circuit is a violation of the 1996 NEC. Safety is the primary concern. 4-wire circuits provide a dedicated grounding path, which is essential for protecting against electrical shocks. Modern appliances, such as ranges, typically require a 4-wire connection for proper operation. Failing to comply with the NEC can compromise safety and increase the risk of electrical hazards. The local electrical inspector may not sign off on the installation, preventing the use of the new range. The correct solution is to upgrade the existing 3-wire circuit to a 4-wire circuit by adding a neutral wire. This can be done by running a new 4-wire cable from the electrical panel to the range location. An alternative solution would be to install ground fault circuit interrupter, or GFCI, circuit breaker in the electrical panel, which will provide ground fault protection. It's important to note that the local electrical code may have additional requirements for upgrading 3-wire circuits. Always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. The 1996 NEC change directly addresses the safety concerns associated with older 3-wire circuits, especially when dealing with high-power appliances like ranges. By mandating a 4-wire system, the code ensures a separate and dedicated path for fault current to return to the source, minimizing the risk of electric shock. In a 3-wire system, the neutral conductor is used for both carrying the unbalanced load current and providing a path for fault current. This can lead to voltage on the appliance chassis if the neutral connection is compromised, creating a potential shock hazard. The 4-wire system eliminates this risk by providing a dedicated grounding conductor that is bonded to the appliance chassis and connected back to the electrical panel. This ensures that any fault current will flow directly back to the source, tripping the circuit breaker and de-energizing the circuit. When upgrading from a 3-wire to a 4-wire system, it's crucial to properly identify and connect all conductors. The 2 hot wires, typically black and red, should be connected to the corresponding terminals on the range. The neutral wire, typically white, should be connected to the neutral terminal on the range. The grounding wire, typically green or bare copper, should be connected to the grounding terminal on the range. It's also important to ensure that the grounding conductor is properly bonded to the metal enclosure of the electrical panel. This provides a continuous grounding path from the appliance back to the source. If running a new 4-wire cable is not feasible, installing a GFCI circuit breaker can provide an alternative solution. A GFCI breaker monitors the current flowing in the hot and neutral conductors. If there is a difference of more than a few milliamps, it indicates that current is leaking to ground. The GFCI breaker will then trip, de-energizing the circuits and preventing electric shock. While a GFCI breaker provides ground fault protection, it does not eliminate the need for a properly grounded appliance. The grounding conductor still provides a path for fault current to return to the source, even if the GFCI breaker does not trip. In addition to the NEC requirements, local electrical codes may have additional regulations for upgrading 3-wire circuits. These regulations may vary depending on the jurisdiction and the specific application. It's always best to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Some jurisdictions may require a permit for electrical work, and the installation may need to be inspected by a local electrical inspector. During the inspection, the inspector will verify that the wiring is installed correctly and that it meets all applicable code requirements. In the specific scenario of replacing a range that was previously hardwired with a 3-wire connection, it's important to consider the existing wiring infrastructure. If the existing wiring is in good condition and meets the current code requirements, it may be possible to reuse it. However, if the wiring is damaged or does not meet the current code requirements, it will need to be replaced. When installing a new receptacle for the range, it's important to use the correct type of receptacle. For a 120/240 volt range, a NEMA 14-50 receptacle is typically used. This receptacle has 4 terminals, 2 hot terminals, a neutral terminal, and a grounding terminal. It's also important to use the correct size wire for the receptacle. The wire size should be based on the ampacity of the circuit breaker that protects the circuit. For example, a 50 amp circuit breaker would require number 6 American wire gauge, or AUG, copper wire. When connecting the wires to the receptacle, it's important to make sure that the connections are tight and secure. These connections can cause arcing, which can lead to fires. It's also important to properly ground the receptacle. The grounding wire should be connected to the grounding terminal on the receptacle and to the metal enclosure of the electrical panel. Upgrading a 3-wire circuit to a 4-wire circuit can be a complex and potentially dangerous task. It's always best to consult with a qualified electrician to ensure that the work is done safely and correctly. A qualified electrician will have the knowledge and experience to properly assess the existing wiring infrastructure, determine the best course of action, and perform the work in accordance with all applicable codes and regulations. They will also be able to identify and address any potential safety hazards that may be present. In conclusion, adding a receptacle to an existing 3-wire circuit is a violation of the 1996 NEC change. The correct solution is to upgrade the existing 3-wire circuit to a 4-wire circuit or install a GFCI breaker. Always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. The rationale behind the 1996 NEC update concerning 3-wire versus 4-wire circuits for ranges and similar appliances stems from a heightened focus on electrical safety. The older 3-wire configuration, while permissible under earlier codes, presented a potential hazard due to the shared neutral and ground path. This shared path could become problematic under fault conditions, where stray voltage could appear on the appliance's chassis, posing a shock risk to anyone touching it. The introduction of the 4-wire system effectively mitigates this risk by providing a dedicated grounding conductor. This conductor ensures a direct and low impedance path back to the electrical panel, allowing for the swift clearing of faults and minimizing the chance of voltage built up on the appliance. The dedicated ground also facilitates the proper functioning of overcurrent protection devices like circuit breakers, ensuring they trip promptly in the event of a fault. Furthermore, modern appliances are increasingly designed with electronic components that are sensitive to voltage fluctuations and require a stable and reliable ground connection. The 4-wire system provides this stability, ensuring optimal appliance performance and longevity. The consequences of violating the NEC, as mentioned, extend beyond mere code compliance. Installing a 3-wire receptacle on a new circuit or failing to upgrade an existing one could lead to several adverse outcomes. Firstly, the installation would likely fail inspection, preventing the appliance from being legally connected to the electrical system. This could result in delays, additional costs for rework, and potential disputes with the appliance vendor. More importantly, a non-compliant installation poses a significant safety risk to the occupants of the building. The potential for electric shock, as described earlier, is a serious concern that could lead to injury or even death. Moreover, an improperly grounded appliance could also damage sensitive electronic components, leading to premature failure and costly repairs. It's crucial to understand that electrical codes are not arbitrary rules but are instead based on years of experience and research aimed at preventing electrical hazards. Ignoring these codes could have serious and potentially life-threatening consequences. The solutions presented, namely running a new 4-wire cable or installing a GFCI breaker, offer viable paths to achieving code compliance and ensuring electrical safety. Running a new 4-wire cable is the preferred method as it provides the most robust and reliable grounding system. However, in situations where running a new cable is impractical or cost prohibitive, installing a GFCI breaker can provide an acceptable level of protection. A GFCI breaker constantly monitors the current flowing through the circuit and can detect even small imbalances that indicate a ground fault. When a ground fault is detected, the GFCI breaker trips rapidly, interrupting the flow of electricity and preventing electric shock. While a GFCI breaker does not eliminate the need for a properly grounded appliance, it provides an added layer of protection that can significantly reduce the risk of electrical hazards. It's important to note that GFCI breakers are not a substitute for a proper grounding system, but rather a supplement to it. Both a grounding system and a GFCI breaker are essential for ensuring electrical safety in modern homes and buildings. When upgrading an existing 3-wire circuit, it's crucial to carefully inspect the existing wiring to ensure it is in good condition. Look for signs of damage, such as frayed insulation, corroded conductors, or loose connections. If any damage is found, the wiring should be replaced. It's also important to ensure that the wiring is properly sized for the load it will be carrying. The wire size should be based on the ampacity of the circuit breaker that protects the circuit. Using undersized wiring can lead to overheating, which can cause fires. When connecting the wires to the receptacle or circuit breaker, it's important to make sure that the connections are tight and secure. Loose connections can cause arcing, which can lead to fires. It's also important to properly ground the receptacle and circuit breaker. The grounding wire should be connected to the grounding terminal on the receptacle and to the metal enclosure of the electrical panel. Finally, it's always a good idea to test the circuit after the upgrade to ensure it is working properly. This can be done using a multimeter to check the voltage and continuity of the circuit. If any problems are found, they should be corrected before the appliance is connected. In summary, upgrading a 3-wire circuit to a 4-wire circuit or installing a GFCI breaker is essential for ensuring electrical safety. Always consult with a qualified electrician to ensure that the work is done safely and correctly.